Hello everyone, welcome back to my channel. In today's session, we will be talking about forward chaining. We will be discussing this along with an example. Let us see the procedure for forward chaining. So in forward chaining, first of all, we'll start with atomic sentences that are there in the knowledge base. And then we apply modus ponens in the forward direction. And then adding new atomic sentences until no further inference can be made. Okay, so that means here we will be starting with the goal, and from the goal we should be able to reach to an atomic sentence, finally a true value or a false value we should reach. Okay, so here what are the new terms that we should learn about? So here we already know what is an inference that I discussed in the earlier lecture. So that is, for example, if you have a statement A implies B and B implies C. So from this, what can you infer? You can infer A implies C. Okay, so that is the inference. That means from the existing clauses in the knowledge base, we have to derive the new one. Then the modus ponens. Can you remember the modus ponens rules? Whenever you have something like P implies Q, that means whenever you have a clause in the form of if P, then Q, and if you know that P is a positive statement or a true statement, then from this, what can you derive? You can derive Q. So this is the modus ponens rules, right? P implies Q and P. So this will lead you to Q. So here that we will be searching for this if-then rules associated with this P. In the if-then rule, on the left-hand side, I should start with this P. So in order to do this, first of all, we have to convert the knowledge base into first order definitive clauses. Whatever data is given, that we should be converting it to first order knowledge base. So that is nothing but disjunction of literals, of which exactly one is positive, which is nothing but a horn clause, right? This we already know. Then a definitive clause is nothing but an atomic or an implication whose antecedent is a conjunction of positive literals and whose consequent is a single positive literal. Here you can see antecedent is nothing but the LHS part. LHS part you can see you have conjunction of two positive literals, king of X, greedy of X. How do you know these are true? So here you have two statements, king of John. So here John is generalized as X and greedy of Y. It is generalized as greedy of X. So when these two are true, so for a complex sentence, we will be using the truth value of the logical AND. So whenever both the statements are true, then it will be giving you a true value. Okay, so we have conjunction of two positive literals, and here you can see consequent, which is nothing but the right hand side. So here also you have a single positive literal. So whenever it is true, this is also true. Since the left hand side is true, from this we can derive that this is also true. So now let's see one example for forward chaining. So here the law says that it is a crime for an American to sell weapons to hostile nations. The country no is an enemy of America, has some missiles, and all of its missiles were sold to it by Colonel West, who is an American. So from this data that is given, we have to prove that West is a criminal. So in order to do that, what we should do? First of all, we should convert this entire data into first order definitive clauses. That means we on the left hand side, we should have conjunction of positive literals, and that should be given in the form of a modus ponens. That means in the form of P implies Q, you should write the rules. So now let's convert the knowledge base into first order definitive clause. So if you first see, it is a crime for an American to sell the weapons to hostile nations. So now let us break this into parts. First thing is American. If person is an American, then weapons here we have, and this is connected with the verb sell. And we also have hostile nations. So this can be broken up into 4 simple sentences. First thing is American of X, then weapon of Y. Weapons we have, right? So this we are replacing with a literal Y. And this sells X is nothing but America. It has weapon Y that is sold to Z. What is this Z? Z is a hostile nation. I'm writing it in short as hostile. So if this is happening, then what will happen as per the law? It is a crime. So then we are writing it as implies criminal of X. Whoever sells, he is a criminal. Then the next statement, the country no, an enemy of America has some missiles. So first we are talking about the no country. So no has some missiles. Okay. So since here we have some, we will be using the quantifier for some X. It is not an, this is called as an existential quantifier for some. So we will be writing it as for some X, no owns X. What is this X? X is nothing but a missile. So here this can be converted. Since here you can see, since you have a conjunction, this is a complex sentence. Let us break this into 2 simple sentences. First one is owns no, comma M1. I am following the standardization procedure. Instead of using the same X for all the literals, I'm using different one. So no, comma M1. M1 is nothing but a missile. I'm using the letter M because it is a missile. You can use anything of your choice in place of this M1. Then the next statement. All of its missiles were sold to it by Colonel West. Okay. So how can we convert this? So here you can see the verb sold. And who is selling it? Colonel West. Who is this person? He is an American. Okay. So now missile of X and owns no of X. These missiles are owned by no and that is sold by Colonel West. So here you can see the form of cells. Here cells is having 3 literals X, comma Y, comma Z. What is X? X is nothing but American. Who is American here? Colonel West. Okay, so there that X, here X is replaced with Colonel West. Then Y is the weapon that is replaced with X here. So why we are replacing with X? Because here I'm taking X for the missile. Here Y is a weapon. That weapon is nothing but a missile. So I'm using X here. Then what is the third one? Third one is Z, which is nothing but a hostile country. What is the hostile country here? No. No is owning the missile. So X is replaced with here this Z is replaced with no. Whenever you are writing a first order definitive clause, you can use different literals. That means this generalized symbol is substituted with a specific value, but you should use the same notation. So here it is having 3 literals. So here also you should use these 3 arguments or 3 literals only. Similarly, if you see owns is having 2. So here also I'm using 2 arguments, no, comma X are 2 literals. Okay, let us see the next statement. That is, the missiles are weapons. So missile of X is nothing but a weapon. X is a missile, then X is a weapon. Then enemy of America counts as a hostile. So enemy of America. So if X is an enemy of America, then X is treated as a hostile. Then the next statement, West who is an American. So we know the fact that West is an American of West. Then the country no, an enemy of America. So here this statement X, comma America. So this X I am replacing with no. So here we clearly know that the country no is an enemy of America. So it is here, given here in the knowledge base. So I'm replacing that X with no here. So these are the first order definitive clauses that we have in our knowledge base. So now from this, how to apply the first order chaining, let's see. So first of all, what we should do, we should start with the goal. What is the goal? This is the goal. So in order, this is our goal. We have to prove that West is a criminal. Here this X should become Colonel West. Okay. So we should prove that he is a criminal. So we will start with the goal and then finally we should end up with the simple sentences or atomic statements which leads to true or false. So now from here, can you identify what are the atomic statements that we have? This is the one, this is the one. Here this is the one and here we have one more. This also we have. So now from these four, out of these four, let us find out, do we have anything on the left hand side with these simple statements? Okay. American of West, here I have. Then weapon of Y. So that weapon of Y I can indirectly derive from this missile of X. Okay. Okay. So now for this goal, what is the left hand side part? Since we are using modus ponens rules, to this, the left hand side part is this one. So let us use the same thing. So here you can see criminal of West. On the left, I have American of X. He has a weapon Y. That will be X, Y, which will be selling to Z and then hostile of Z. Okay. So the left hand side I have written here. And since it is connected with all ands, here you can see I'm using an arc which indicates and. This is like an under graph. If you already have an idea of under graphs, that will be discussed in design and analysis of algorithms. So this arc indicates an AND node. If there is no arc, that is an OR node. Okay. So that means all these must be solved in order to get the solution, this criminal of West. That is the meaning of this AND node. Okay. So now, yes. So for this weapon of associated with this weapon of X, here, weapon of X, what is the LHS part of this? We have missile of X. So I'm writing missile of X here. Then associated with this cells, what do we have? Cells comma West, cells of West comma X comma no. On the left hand side, what do I have? Missile of X and owns. Two statements I have. So I'm introducing owns of no comma X, and in order to get this, I need to solve these two. So again, I'm making this as an AND node. Here you can see the arc, which is an AND node. Then hostile of no. So associate on the right hand side, you should have this hostile of X. So associated with this, the left hand side part is enemy of X comma America. Enemy of X comma America. So from here, what I have in place of X, I have no. The same thing I'm substituting here. And here, I want to prove criminal of West. So my X is standing for West here. And then missile M1. So this I will be back substituting here in place of Y. I will be replacing that with M1. Then in own, so I have no comma M1. So this Y I am replacing with M1. And here in place of American of X, I have West. So that I am substituting here. And here already no is substituted. And if you observe, all these are our atomic statements. American of West. So here you can see American of West is an atomic statement. Then missile of X, which is derived from weapon of X, is also an atomic statement. Then owns is an atomic statement. This one, missile of M1, this is an atomic statement. This is an atomic statement. This is an atomic statement, and this is also an atomic statement. and we reach to these atomic statements. So with this, we are done with our forward chaining. The same thing, let us understand with the help of an algorithm. Here, the name of the algorithm is first order logic forward chaining. What it is asking, already we discussed about ask and tell. What it is asking, the knowledge base, it is asking about alpha. Okay, so here alpha is nothing but the query or an atomic statement. KB is the knowledge base, which is nothing but a set of first order definitive clauses. And you can use a local variable called new. Okay, whenever a new statement is inferred, that we will be adding to the knowledge base. So for that, we are using this literal new. Then you have to repeat this algorithm until new is empty. All these steps we should repeat. Initially, new is empty because no new rule is being generated. Then for each rule in the knowledge base. So what is the rule form? It should be in the form of modus ponens. Okay. And then you just standardize the variables. Okay. Instead of using the same variable name for different propositions, we will be using different names. That is what meant by standardization. Then when you can substitute theta. So whenever you have similar statements, so P1 and P2 and P1, so this and P dash, P1 should be equivalent to P1 dash. Pn should be equivalent to Pn dash. In that case, I can go with a substitution theta. And also, I will be substituting this theta comma q in place of q dash. If q dash does not unify with some sentences already in the knowledge base, if it is not there, then we will be adding this q dash to new, and then you will try to unify it and you add it to the knowledge base. Okay. Then if phi is not fail, then we will be returning. What else? That means you have derived some new knowledge, so that you will be adding to the knowledge base. The phi will be returned and you will be adding new to the knowledge base. Otherwise, it returns false. Let us see our example. So here, this criminal of West, our P implies Q form, we should check, right? So left hand side, I have one second. I'll just hide these controls. Yeah. So on the left hand side, I have American of X, weapon of M1, cells of West, comma M XYZ, hostile of Z. Okay. So this is implying to criminal of West. Okay. Yes. I have a rule in this particular form. So then what am I doing? Here I am using a substitution. Okay. So here criminal of X, X is replaced with West. Okay. X is replaced with missile M1. Then here enemy, the hostile country, Z is replaced with no. So all this is happening. So we are substituting theta in place of Q, and this you are modifying it as Q dash. And if this is not already there in the knowledge base, you need to add it. Otherwise, you will return phi is not fail. Then you will return phi and you will be adding that to the knowledge base. So from this, what I will be adding to the knowledge base, missile of M1 and wounds of no. So these two I am adding. And if I solve these two, I will be getting cells of X. And then from this, I can add enemy of no, comma America. So actually all these statements, whatever we have written in the previous statement, so that we have done one by one. So that is what we are adding to the knowledge base. That is nothing but our new. So we have started with the first rule. One second, let me move to the previous slide. Yeah. So we have started with this one. This is our base statement, right? So we started with this one. This is our goal statement, P implies Q form. And from this one by one, we were deriving. Associated with this, whatever related information is there in the knowledge base, that we are adding into new alpha. So this is how your forward chaining algorithm is going to work. Hope you followed. If you like the content, please do like, share and subscribe. I need a lot of subscribers. That will be an encouragement for me. And if you skip the contents, I can't assure you that you will get the entire information. So please don't skip the information. If you have any queries, please let me know in the comment section. Thank you.